Calc 3, problem number 2 from the optional exam. Alright, number 2 from the optional exam. Find the scalar and vector projections of A equals 2, negative 1, 4 onto B, 0, 1, 1/2. Alright, so the scalar projection of A onto B is written as A dot B over magnitude of B. Rewrite that as a better B. B. Vector projection A onto B is project B to A of A dot B over times B over magnitude of B. Alright, so let's find A dot B. Let's do 0 times 2 plus 1 times negative 1 plus 1/2 times 4. 0 minus 1 plus 2 equals 1. That's our A dot B. Magnitude of B equals square root 0 squared plus 1 squared plus 1/2 squared equals square root of 1 plus 1/4, which equals square root 5 over 4 equals, which can be rewritten as square root of 5 over 2. Alright, so then we just put our values back in. Scalar projection equals 1 over square root 5 over 2, which can be written as 2 square root 5 over 5. Our vector projection of A onto B is written as 1 square root 5 over 2 times 0, 1, 1/2 all over square root 5 over 2. Multiply it out, we get 0, 1, 1/2, 5/4. Normally for scalar and vector projections, it's B onto A, but in this case, it's A onto B. Alright, part B, show that magnitude of A cross B squared equals A squared B squared minus A dot B squared. Alright, let's start by remembering A cross B equals A B sine theta. Magnitude of A cross B squared equals A squared B squared sine squared theta. And this can be rewritten as A squared B squared 1 minus cosine squared theta. Factor it out here. A squared B squared minus A squared B squared cosine squared theta. We can remember over here that magnitude of A, magnitude of B cosine theta is A dot B. So now we can write this as A squared B squared minus A dot B squared, which we have proven or shown that this equals that. So that's how you find number 2, part A and part B.